Hello and welcome, statisticians. I had a few questions on the same problem, so I figured I'd just record a quick video. So we're looking at 6.5 section on central limit theorem, and this is number 14. We have a company producing steel rods, and the length of these steel rods are normally distributed with a mean of 182.6 centimeters and a standard deviation of 1.9 centimeters. For shipment, we have 18 steel rods bundled together. Anytime we hear that bundle or a group of things or a collection of things, we want to think to ourselves, we need to adjust that standard deviation. And so here we're looking, the question is find piece of 40. So as always, we'll draw our picture of this normal distribution. See if I can get it somewhat symmetric there. And our mean here is 182.6. So this is our diagram, a rough sketch. We want to find the 40th percentile, which is the average length separating the smallest 40% of the bundles from the largest 60%. So we know here with the percentile, we have some x here, some value that cuts off 0.4 down here, or 40%, from the largest 60% above. And we're looking for that x, that cutoff value that separates the two. When we're looking for the cutoff value and we're given a percentile question, we know we need to go to the inverse calculator. So I'll come back over here. Here's the normal distribution calculator. I want to go to the top here and switch on our toggle to inverse norm. And so we could do this one of two ways. We could say 40% below, or we could say 60% above. Either will give us the same solution. I'll go, just to stay consistent, we'll put 40% below, and I think this is 182.6 for my mean. I've already forgotten. What is it? 182.6 and 1.9. There we go. 1.9 for our standard deviation. But here's the trick. For our standard deviation, we have to adjust this. Break out my calculator here real quick. We have to adjust our standard deviation because we're looking at a group of things. So we want to take, let's go back to this screen real quick. So in this circumstance, we can't just use 1.9 as our standard deviation. We want the standard deviation for the sampling means, which will be 1.9 divided by the square root of n. Our n here is a group of 18. So the square root of 18 is our value there. We'll solve for that first. So 1.9, I'll divide that by the square root of 18. Should be a little over 4, right? All right, I have 0.44783,42948. You want to use at least 5 decimal places when you put this into the calculator and not round too early because that will throw your answer off. So 0.44783, I think that will work. And we want below for 40%. So I have 182.48. And this is asking us to round to 2 decimal places. And so we'll check that again. That was 182.486. That 6 will move the 8 up to a 9. So 182.49 is our solution. The next question that we have is question number 15. So let me copy this over real quick so that I can write on the problem. I'll do 14 and 15 all in one video. There we go. Okay, so now we can write on this. We have the town of Nowhere, Spatial, USA, and it's operating a rubbish waste disposal facility. It's overloaded if its 4,825 households discard waste with weights having a mean that exceeds 27.21 pounds per week. For many weeks, it's found that the samples of 4,825 households have weights that are normally distributed with a mean of 26.79 pounds, standard deviation of 12.22. What's the proportion of weeks in which the waste disposal facility is overloaded? So we said it's overloaded if that mean is greater than 27.21. So we know we have a normal distribution. We can draw our little sketch over here. Our mean is, let's see, 26.79. Standard deviation for single items would be 12.22, but we're looking for the average. And so we want the times when the mean is greater than 27.21. That looks like this. We're looking for means, so we know we want to adjust that standard deviation. So let's take the standard deviation here. We want the standard deviation for the sample means would be, let's see, our regular standard deviation, which is 12.22, divided by the square root of the large number of households, which is 4,825, which is roughly, let me grab my calculator, clear this out, say 12.22 divided by the square root of 4,825. That gives me 0.1759, let's see, 1759229. There we go. All right, let's see if I can remember that from one screen to the next. 1759229. Oh, I have to go back to normal distribution. We were on inverse from the last problem. Switch this to normal. Go back to check my numbers here. 26.79 was our mean. Our standard deviation, I have to check that again. 0.1759229. And we're looking for above, what was our cutoff there? 27.21. We went above 27.21 and hit recalculate. I get 0.0085. And it's asking for the number accurate to 4 decimal places, which we have. And then the next question is this an acceptable level or should action be taken to correct a problem of an overloaded system? So we have to think back. What is that 0.0085 telling us? What question are we actually answering here? And so this is the proportion of weeks that the disposal facility is overloaded. If we put this into a percentage, we think of this as a percentage. We have our answer is 0.0085. To change that to a percent, I would multiply by 100, or a lot of people think of that as just moving the decimal place twice to the right, which is 0.85%. So really, if we think about this in the big scheme of things, it's 0.85%, which is not even 1% of the time that the system is overloaded. So really, this is an acceptable level. It's less than 1% of the time. So hopefully this was helpful. Again, this is number 15 from section 6.5. If you have further questions, feel free to send me an email or give me a call. Thanks.